A geometric progression, also known as geometric sequence, is a sequence of numbers where each term after the first one is found by multiplying the previous one by a fixed non-zero number called common ratio. Then we have three pictures for the common ratio: the first one, the second one, and the third one. For example, the sequence 2, 6, 18, 45 is a geometric progression with common ratio 3. Similarly, 10, 5, 2.5, 1.25 is a geometric sequence with common ratio 1/2. The sum of the terms of geometric progression is known as a geometric series. A geometric sequence can be written as this, and where the q is different from 0 and q is the common ratio and also is a scale factor. The formula for the nth term can be defined as this. If the common ratio is negative, then the result will alternate between positive and negative. If it is greater than 1, there will be exponential growth towards infinity and it will be positive. Less than 1, there will be exponential growth towards infinity and it will be positive and negative. It is less than -1. And between 1 and -1, there will be exponential decay towards 0. And when it is 0, the result will remain at 0. Then we have the geometric progression properties, which are two types, the first one and the second one. And we have two formulas for them. Then there is a mathematical problem, which is three types. The first type with the formula, and we're searching for q. We have two examples. In the first example, we have two results after calculating the numbers. The first one is q, which is equal to 3, and q equal to -3. In the second one, we have n, which is equal to 3. And there is a story about...
According to a famous legend, the ruler of India, charmed by the chess play, asked what its inventor wanted. The inventor asked to be paid in grains, as for the first square of the chess table to be given 1 grain, for the second square 2 grains, and so on for each following 2 times more. The ruler said that this request was very modest, but did he manage to pay? In order to find out the quantity of grains, we have to calculate the first 64 terms of a geometric progression with common ratio 2 and scale factor 1. We use the formula of sum of the geometric progression, and we can calculate with the help of computer this number. Taking into consideration that 20 zero grains weigh averagely 1 gram, the inventor of the chess play asked for about 900 billion tons of grains, which is 1500 times more than the quantity of wheat produced in the world now. So obviously the ruler, who did not know mathematics, strongly underestimated the request.
Then there is a second type for which we have another formula, this one, and the example, which is the same as this one from the story, and with the help of a computer we can calculate the result, which is this long number. Then the third type is a system, and we are looking for A1 and Q, where we have A4, A2 and A3. After calculating, the results are for Q2 and for A1 also 2. Then the next slide is a text mathematical problem, which is the bank has a president, 3 vice presidents, 9 head of management, and so on until the 6th level, where is a common clerk. How many employees does the bank have? We have A1, which is 1, and Q, which is 3. After calculating the formula, the result is 364. Then we have a table, and we have to fill the gaps. And that was our presentation, me and Maria.